think you guys are going to need a calculator. But anywho, all right, the first question, complex fraction. Complex fraction just means a fraction within a fraction. So like I have, if you look at that first example, I've got a fraction stacked on top of another fraction. This is, I mean, it looks kind of garbagey because it's like this huge problem, but really this is just your keep, change, flip. So all I'm going to do to the top here, let me just keep the 6 and the x plus 2. I'm going to change that division to multiplication, and what I'm dividing by is the same as multiplying by the reciprocal, so we're just going to flip it over. So then the x plus 2 would go to the top, and the 2 would go to the bottom. Now, we're just going to leave these, if we're not already, in factored form. So if I went ahead and multiplied straight across the top and bottom here, which I would do, these guys would cancel each other out, and you can maybe reduce this, but I'm going to write it out. So literally we'd have a 6 left on the top and a 2 left on the bottom, and if you can divide that, which we can there, you're totally allowed to do that. The answer to that question is actually just 3. Now, in terms of your restrictions, anything that would make the denominator 0 at any point. So this first fraction, x plus 2, is in the denominator, so I don't want x to be negative 2 because that would cause us to divide by 0. And actually this fraction also had x plus 2 in the denominator, so that wouldn't add an extra restriction because that's the same restriction we'd get from the fraction on the top, but you still do have a restriction, anything that would cause a denominator at any place in the problem to be 0. Okay, now the rest of these are a tiny bit more complicated and are going to bring in kind of some of the skills that we were talking about right before we left on spring break. So this mess is also a complex fraction, so just a fraction within a fraction, but it also includes a sum on the top and a sum on the bottom. Easiest way I can tell you to do a problem like this is actually just to kind of work with the top and bottom separately and then do your keep, change, flip. Okay. Now, here's what I need to do. I have to add 1 over x to 3. What I'm going to do, anytime you have a plain number or plain variable, you can just write it over 1 real quick to turn it into a fraction. If you guys remember, if you add fractions, you do have to have a common denominator. Okay, so what would I use as my common denominator between 1 over x and 3 over 1? Anybody know? What would common denominator between x and 1 be? It has to be x, right? Okay, so all I'm going to do, top and bottom, it can be a variable, that's fine. Top and bottom here, I'm going to multiply by x. All right, what that's going to do is not too much. We're just going to have 1 over x plus 3x over x. And don't be tempted to simplify. I feel like when we start doing these problems, people get confused and they try to simplify. No, we want that common denominator. Now, when I add these together, all I'm going to do, the x is going to be on the bottom. That's your common denominator. On the top, I'm just going to put the 3x. We're adding these together, so I'm going to put 3x plus 1. Just so it's in kind of standard form, what you guys are used to seeing there. So just put the 3x in front of the 1, but I'm still adding them together. You can't simplify that in any way. All right, now, all I'm going to do, we're just going to do the same thing to the bottom. So we'd have 5 over x plus 4. So I'm just going to write the 4 over 1 so I can turn that into a fraction. And this is super similar. The common denominator there, bless you, is also going to be x. And so here I'd have 5 over x plus 4x over x. And then we're actually just going to add across the top, keep the denominator the same once you got that common denominator. And I'm going to do kind of the same thing I did above. I'm just going to write the 4x first and the plus 5 second. I'm still adding them together. I'm just kind of writing it in standard form. Okay, now I know that was kind of a lot of work, but to actually divide these, I'm just going to do my keep, change, flip. So the top is in green, that's the numerator. The bottom, that's the denominator, is kind of in that pink color. So I'm just going to keep the 3x plus 1 over x, change that division to multiplication, and when I flip this over, the x would go to the top, the 4x plus 5 would go to the bottom. Now, in this particular problem, if you can factor something, you would want to try to do that, but like 3x plus 1, there's no common factor. 4x and 5, there's no common factor. I can, however, I have an x on the top and an x on the bottom. If I'm multiplying these, I can cross those out, but nothing else is going to cancel here. So the top, you'd have 3x plus 1 bottom 4x plus 5, and you really can't do anything else there. Now, in terms of your restrictions, anything that was in the denominator that could make a denominator 0 at any point in the problem, you got to exclude that. So for both of these that we worked on, we had x in the denominator. So what would my restriction be if I just have an x in the denominator? What number? 0. Okay, what then at the end, when we actually multiply this 4x plus 5 ends up in the denominator, what would be the restriction for 4x plus 5? Gotta be a fraction. Perfect, negative 5 over 4. And if you're like, what the heck, where did he get that? Just take like 4x plus 5. I just try to, you don't want that to be 0. I just kind of think about it in my head. So I'm like, okay, what would I do? You would subtract 5, and then you would divide by 4. And I usually don't write all that out, but that's where that negative 5/4 is going to come from. Does anybody have a question? Okay, these kind of get harder as they go. All right, now I have another complex fraction, right? Fraction within a fraction, and this one's going to involve some subtraction on the top and bottom. So the top of that, I have 6 over a minus 3 over b. So let me lay this here. We'll just look at that for a second. What would a common denominator between a and b be? It's AB. Okay, now this is the deal. Whenever you guys have two letters within the same term, we usually write them in alphabetical order. So when I get my common denominator, I'm just going to write it right in the problem here. This one would need a B, top and bottom. This would need an A, top and bottom. All right, so I'm just doing the top of that fraction there. Now, this would be 6B, but I'm going to write the denominator as AB, just in alphabetical order. And I'm going to subtract from that 3a over ab. And then my common denominator would just be that ab. And on the top, we're just going to actually subtract. But you can't actually subtract those guys, right? Because you have 6b minus 3a. They're not like terms. So I'm going to literally just write 6a minus 3b. Okay, now, just before I do anything to the bottom, does the top of that fraction, 6b minus 3a, have any greatest common factor? And it doesn't matter if the variables are different. Like, do 6 and 3 have anything in common? Perfect, they're divisible by 3. Okay, so if I take a 3, I'm just going to try and write that in factored form, 3 out in front. What would be left if I took a 3 out of both of those terms? Perfect, 2b minus a. I'm just kind of doing this as I go if I can. Sometimes it's helpful, sometimes it's not. Okay, super similar on the bottom. You have one denominator is an a, one's a b, so your common denominator is going to be ab again here. The first fraction, top and bottom, needs a b. Second fraction, top and bottom, needs an a. So that would result, you'd have 8b over ab, just writing that in alphabetical order, and then minus 4a over ab. So we can't actually subtract on the top there, so it would be two separate terms, 8b minus 4a over ab. And then I'm just going to ask you real quick here, do 8b and 4a have anything you could factor out? What would you have left? Yeah, and then you're going to be like, oh, magic. Look at that. That happens a lot. All right, so here we're going to do our keep, change, flip. So I'm going to keep the numerator. And I'm just keep it in factored form. It makes it easier to find restrictions, and it also makes it easier to cancel things out. So that's just the numerator. I just kept that the same. I'm going to change that division to multiplication, and we're going to flip this guy over. So the AB would come to the top, and the 4 times 2b minus a goes to the bottom. Now, if we're multiplying, which we are now, anything that in the top matches something in the bottom, you can cross it out. So you got this 2b minus a, top and bottom, that's gone. You got an a, you can cross out. You got a b, you can cross out. And literally all that's left is the 3 on the top and the 4 on the bottom. And that's going to be your answer. Okay, now the restrictions on these are a little bit weird. So if you look at the original problem, I just had a plain a in the denominator, right? So a can't be 0. I had a plain b in the denominator, so b can't be 0. And that was for both fractions within the top and bottom of that complex fraction there. The restriction that I think becomes weird is this guy right here, the 2b minus a. You can't really tell me, okay, like b can't be 3 or something there. You can't do that because you got two different variables and it's not something you can simplify. So I'm going to show you two different ways to write this. But basically that 2b minus a, there's two different variables in there, so we don't know what we could plug in that would make that equal to 0. So that expression, I don't want to be 0. And if you want to write the restriction like that, that is completely fine. I just want to show you one quick thing. A lot of times in like a textbook or something, they would almost kind of like solve this little inequality, just trying to maybe simplify it a little bit, maybe would write the restriction like 2b can't be equal to a. So either one of those are equivalent, but when you write your restriction, if you got a couple terms here, like either one of these is fine. If you got a couple variables within the same set of parentheses, you might have to kind of write your restriction in that format. So either one of those, whichever one you like better, is fine with me. Does anybody have a question? Okay. Now we're going to do a couple weirder ones on the back. All right, now, the top of this first fraction, if I can get this on the screen. Okay, you're not doing anything with that, right? There's nothing to simplify here, so that would just be the same. All right, now the bottom, we have a little subtraction. So I'm going to take that 2 and write it over 1, because we're going to need to create a common denominator anytime we add or subtract fractions. Okay, so if I just have the 1 and then I have the x minus 4, to get that common denominator, you just need an x minus 4, right? Now, what I'm going to do on the top of that fraction, since I had a 2 in the top already, we're going to have to do like a little distributive property here. So we would have 2x minus 8, that's over the x minus 4. And then from that, I'm subtracting, it was just a 3 over x minus 4. And then once we've got our common denominator, you just keep that the same. And I'm actually just going to subtract across the top. So I have 2x minus 8 and then minus 3. So if you simplified that, you'd have 2x minus 11. And then remember, I didn't really change this, and you don't have to keep rewriting it, but the numerator was that 3 over x minus 4. Once you're there, we're just going to do the keep, change, flip. So I would keep the 3 over x minus 4, change that division to multiplication, and when I flip that second fraction we worked on over, the x minus 4 goes to the top, 2x minus 11 goes to the bottom. Now, if you're multiplying, right, these guys match, so we can cross them out. Nothing else cancels, nothing else factors here. So we would have a 3 on the top, and then just 2x and 11 don't have anything in common. So you can't pull out a greatest common factor or anything like that. That would just be your answer. Now, places for your restrictions at any point in the problem if the denominator could be 0. So in this first one, you have the x minus 4, so we don't want x to be positive 4. And then in the end of the problem here, we got this 2x minus 11 in the denominator. So if I set that equal to 0, we'd add 11 and divide by 2. So 11 over 2 would be your other restriction. Does anybody have a question? Okay. Now this one's a little bit different. This one you're not going to be able to do anything in terms of the bottom because it's not actually adding or subtracting, but we got to work on the top here a little bit. All right, so I have 4 over x plus 4, and I have 8 over x plus 5. I'm just trying to give myself a little space here. Now, you can't just add and subtract things out of the denominator. It has to be multiplication to create a common denominator. To do that here, you're just going to need whatever you're missing. So this one has an x plus 5. It needs an x plus 4 to make those match. This one has, the first one has an x plus 4, so you need an x plus 5 top and bottom to make it match. Now, what I would recommend there, don't FOIL the bottom. Just leave it in factored form. It'll make it easier to see the restrictions, and it'll also make it easier to see what you're working with. You do have to work on the top, though. You do have to do just a little, bless you, little distributive property here. Okay? So, on the top of that first fraction, we'd have 4x plus 20. Don't go back and factor it. X plus 4, x plus 5. And we're adding to that, so I'm going to just multiply those two terms by 8. So we've got 8x plus 32, x plus 4, x plus 5. And if we actually add them together, once you're there, just the bottom is going to stay that x plus 4, x plus 5. And across the top, just combine, I'm totally off the page, guys, I'm sorry. Just combine like terms. So 4x and 8x, you got 12x's. And 20 and 32 is going to give you 52. Now, the bottom of that fraction, which I haven't even looked at all, you have 3x plus 13, which you can't do anything with. The bottom, though, is x squared plus 9x plus 20. Can anybody tell me this? You can factor the bottom of this. What would you have that would multiply to get you 20 and add to get you 9 for the factored form of that quadratic? Can you think of two numbers? Yes. And you guys are going to notice, keep that in factored form. You're going to notice that that matches that other. All right, so I'm going to do my keep, change, flip. All right. Oh, actually, hang on. Before I do that, can you, we have that 12x plus 52 on the top. I got to have at least a 2 in common there. Is there a bigger number? I think, does 4 1? I think 4 might go into both of those. So I'm just going to factor the top of that. I think we can take a 4 out. So if I take a 4 out of both of those, you'd have, let's see, 3x plus, I'm pretty sure 52 is divisible by 4. Let me see. Yes, okay, 13. So on the top there, I'm going to do my keep, change, flip, but I'm going to leave it in factored form. So the top, once I just factored it there, 4 and then that 3x plus 13. The bottom, x plus 4, x plus 5. I'm going to change that division to multiplication, and then when I flip that over, that quadratic actually exactly matches what we had, the x plus 4, x plus 5. So those are going to go. And then actually on the bottom, I have that 3x plus 13. That we can actually cancel as well when I took that greatest common factor. So literally everything cancels here except that 4 that we factored out on the top. So the answer here actually is just 4. And then in terms of my restrictions, you got to go back any point in the problem. If your denominator has a variable in it, you got to exclude anything that could make it 0. So if I go back, we have the x plus 4, x plus 5. So -4, -5, both problems. The only other thing that ended up in the denominator was this 3x plus 13. So if you set that equal to 0, you would subtract 13 and divide by 3. So that third restriction there is going to be -13 over 3. Okay, this last one, I'm not going to lie to you, this last one is super weird. Okay. And then we'll be done. All right, so let me have you guys just look at the top of the fraction for 1 second. And I'm going to grab a different color, and I'm just going to come over here real quick. Let's say I just gave you the quadratic x squared minus 49. Difference is squares, right? Does anybody remember how to factor that? Plus or minus 7. Okay, so this would be x plus 7. Doesn't matter which one comes first or second. Okay, so this is a little weird, but the top of this fraction that you have on the top of this complex fraction, the numerator here, the top part, is actually a difference of squares. It's really similar to this, but it has a y squared instead of just a plain 49. Does anybody know how you can factor x squared minus 49y squared. Like, what would the two factors look like? Eli, what do you think? Yes, okay. And again, it doesn't matter which one comes first or second, right? If you want to put the plus first and the minus second, that's the same thing, all right? So, a little weird, but leave it. All right, now, that's really all you can do on the top. Is just factor it, because we're not adding or subtracting. It just has one really gross-looking fraction on the top of it there. The bottom is going to be similar to some of the problems we had a little bit on the front. We got to add, so we got to create a common denominator. Okay. Now, you have a y and an x, so I'm going to need a y and an x. So this first fraction would need an x multiplied with the top and the bottom. The second fraction would need a y multiplied with the top and the bottom. All right, so you would have x over, and again, I'm just going to take, and if I've got two letters in the same term, just write them in alphabetical order. So I would write xy. That way we can tell what we have there. Then we'd have 7y over xy. And to actually put that together, it would look like x plus 7y over xy. And then we have our numerator, which I'm going to be lazy here and not write again. Okay, now if I do my keep, change, flip, I'm just going to leave it in factored form. We had that x minus 7y, x plus 7y, all over xy. And I'm going to take this fraction once we added it together. We're going to flip it over. So the xy goes to the top. And then we have this x plus 7y that goes to the bottom. And a bunch of stuff cancels here, right? So we have x plus 7y top and bottom. You have an x top and bottom. You have a y top and bottom. What will be left here, we just actually cancel the entire denominator out. So you just have x minus 7y left on the top. Now, even though the denominator canceled out, we have to go back and exclude anything that would make it 0. So you have a plain x and a plain y in multiple different parts of that beginning of that problem. So you don't want x to be 0, and you don't want y to be 0 for your restriction. And then the other one, we have kind of this weird one right here. Can't just tell me like x can't be 6 here. So I have the x plus 7y. I've got the two variables, so I can't really say a specific number, but I don't want that expression to be equal to 0. That would cause my denominator to be 0. And if you want, like I was telling you before, sometimes these little inequalities, they almost kind of just solve like a little bit. So maybe they'd subtract 7y and say x can't be equal to negative 7y. Those are the same restrictions. So whichever way you want to write it is fine with me. If you want to just take what's in the parentheses and say that's not equal to 0, that's fine. Okay, does anybody have a question?